Hi everyone. Uh, let's continue with yesterday. We faced some troubleshooting issues. The sub interfaces were not getting created properly. So let us now we have basically this is the direct internet access, basically granular control. We want to provide internet access maybe only to a certain segment, basically certain department. Like yesterday we have seen, so we had created VLAN 10 and VLAN 20. I put VPC in VLAN 10, I put router 11 in VLAN 20. I created basically, before I started, yes, yesterday, for testing purpose, I created a VLAN interface on the switch. So when I'm pinging from this PC 10.0.111.254, this is the VLAN 10 IP. So if you see, this is pinging, that means the connection, VPC connection to the switch, the VLAN configuration is working. Same way, let us go to router 11. Is router 11 here. From router 11 is in VLAN 20. So let me ping 10.0.20.254. And there you see router 11 is also able to ping interface VLAN 20 on the switch. So the switch configuration is okay. And the switch also has a this thing, basically a trunk interface. The interface towards LAVH1 basically is a trunk. So when I do show interface trunk, it is showing Ethernet Z0/1. So that is what is needed actually. This is what is needed, trunking. So we created sub interfaces. For creating sub interface, what is the requirement? The physical interface must be in VPN 0. Physical interface must be in VPN 0. That is the requirement. And then you create the sub interface. And second thing is that sub interfaces MTU has to be lower than the physical interface MTU. Why? Because frame tagging will happen. That will increase the frame size. So that's the reason you have to lower. So that is what we lowered basically. That is what, let us go to now the, sorry, here.
Sir, one small thing.
Yes, please.
Sir, that yesterday you reduced 4 bytes, but in .1Q2 we require 2 bytes only, right? So is there any reason for this one that?
No, as I said, no, it can be anything basically. You have to reduce the MTU. I could have made it 1490 also.
Okay, understood.
I just kept it 4 byte lower than that, basically.
Okay,
1500.
Okay.
We can keep it anything, but no, keeping it too lower also will not be good, basically.
Okay.
So before I started the session, I was checking this physical interface, this thing, feature template, physical interface gigabit 0/2. I was just checking anything is wrong, anything missing. So normally the physical interface must be no shutdown. I clearly specified it is gigabit 0/2. It does not require, physical interface will not have an IP address. So I made it default here. IP is like that. We can keep it dynamic also, but if I make it let's try with this now, because by default when we create an normally on a router, when we do sub interfaces, we define the encapsulation that okay, this sub interface will belong to this VLAN. Basically we specify encapsulation.1q and the VLAN ID. This is here, I'm not getting that basically. How? That is why I'm wondering why this is not happening. But anyway, we'll not waste time. Why? Because we have one more lab, that is a TLOC extension basically. Let me open up, because in that also sub interfaces will be there. So we'll come together, we'll try to do that. Let me just for you guys reference course blueprint PDF. So if you see here, redundancy requirement like that, okay, using a feature. So basically, as we can, so in this also there will be creation of sub interfaces. So that will troubleshoot, will create the sub interface here also, and then we'll see why something is going wrong, just like that. Because I restarted the lab also, I checked on the LAVH1 also. LAVH1 I checked, basically you see physical interface basically is already in VPN 0. Physical VPN 0 physical interface is part of VPN 0, gigabit 0. And then basically I checked VPN 100. In VPN 100, MTV is lowered, it is no shutdown, its IP address is there, like that. So it is showing everything basically. So that's the reason I will not waste time here basically. I'll explain the lab, the last lab, because that is an important lab. Then we'll come back together for this lab 18, granular control. Lab 19 we already done yesterday. It was a simple through the feature templates. We were able to provide internet access, but it was basically what? Full internet access. It is full internet access. Why? Because all the resources in VPN 100 will get the basically internet access. But next lab was, I wanted that, okay, with custom we can customize it so that only certain departments, certain segments should get the internet access, and that is why we created VLAN 10 and VLAN 20. Unfortunately, the sub interfaces on the LAVH1 is not responding. When I ping from here, ping VPN ping IP address 10.0.111.254. This is the interface VLAN IP of the switch, and I say this is basically in VPN 100. So this is where the problem is actually on LAVH2, because it's not pinging, it's not working. So we'll troubleshoot this. After that, it will be matter of minutes to configure the internet access. So for the time being, let us keep this internet access, this lab basically. Okay, right. For the time being, let us keep this lab 18 aside. We move to the final lab 20. That is called as what? Redundancy requirement for branches having single WAN service or transport. And so what is the meaning of this basically? This lab basically, if we see the topology, okay, in one location basically what the customer has, the customer has only one VH, like that. They have only one VH, so, and they have taken only one WAN service, like LAVH1 now. LAVH1, they have taken up only one WAN service, like that. And then basically there could, in this organization, in the same location, in the same branch, there could be another like it could be another department or another vertical, like that. And now they also want to have basically connectivity to the data center and all. So what happened? they this organization, they arrange another VH. They another VH they connected, but now this department, they took the service as what? MPLS. Here they took the service as what? Internet. Now the problem is what? They are working, let's say these two departments are basically different, or this could be two different verticals in the same organization, like that. They are basically different basically. Now the problem is what? Whenever this data traffic is going from the LAN or whatever is behind basically in the service VPN through LAVH1, as long as this internet is there, the traffic will flow. When internet fails, these users cannot, basically the users cannot access. They're not able to access the company resources basically. They're not able to access this company resources. Same thing is with the other vertical. These guys also they have taken only one WAN service. They do, because that much traffic is not there. This organization, maybe they don't have that many users. So the company doesn't want to basically, go in for a dual transport basically. They say since the business volume is not that much, it does not justify to add a new basically van service for this each department. So now what is happening? They say, okay, if this MPLS fails, then they also get isolated like that. But now in Cisco Viptela SD-WAN, what we have basically is we have something, a feature called as what? Just hold on, let me open up my diagrams. So we in Cisco Viptela SD-WAN, basically we have a feature which is called as what? T-lock extension. It is called as what? T-lock extension, like that. Why? Because every WAN edge, in SD-WAN fabric, for all the destination, for any prefix to send and receive any prefix, the next stop is not like the IP address. The next stop is known as what? The T-lock, like that. And that's the reason this feature is called as what? T-lock extension feature. What is this T-lock extension feature? T-lock extension feature provides basically redundancy, router redundancy to the WAN edges basically. That means now what happens? See, this is LA. I have written here LA1. LA1 has internet connectivity, and this has, let's say, this is LA2. It has basically MPLS connectivity. So, and same scenario, I've drawn the diagram here. So if you see now LA1, normally how the traffic from the VPC will go, it will come to LA1. LA1 will forward through the internet, and it will go to wherever it wants. Same way this router 11, if it wants to go to the internet, it will send the traffic to LA VA2, and then VA2 through MPLS cloud will send it to data center. It can access Dubai, it can access New York. So all the locations this router 11 will be able to access normally. But whenever there is a failure here, they get isolated. So now what is my requirement? The requirement is what? That if internet fails, see, I'm going to use a different color now. If internet fails, the traffic coming from to LAVH1, what LAVH1 should do? It should forward the traffic to LAVH2. It should forward the traffic to LAVH2, and then LAVH2 will forward the traffic through its WAN service. And now what happens? If you see LAVH1, this department, this vertical, now basically, even if their primary internet is failing, they're sending the traffic through an alternate path. This is called as what? Backup or redundancy. So T-lock extension is nothing but a backup solution, okay, providing redundancy basically, WAN edge redundancy basically, or basically rather it is not WAN edge redundancy, it is basically the WAN service, the WAN transport redundancy. Same way, if there is a failure, in this MPLS cloud, and then what will happen? LAVH2, what it can do? It can send the traffic. If it receives any traffic from its backend, basically, what it will do? It will say, oh, hey, I will do one thing. Whatever traffic I'm receiving from my this thing, what I will do now? I'll forward this thing to this guy, to LAVH2, and then LAVH2 will forward the traffic through its internet, through its WAN service, whatever is the WAN service, and like that. So like that, they are going to provide, backup to each other. When we implement this, this is called as what? T-lock extension. This feature for backup is known as what? T-lock extension. Okay, guys, clear everyone? What is T-lock extension? T-lock extension is a feature by which we can provide a backup or a redundancy solution whenever the WAN transport, whenever a WAN edge has only one WAN transport and that fails. So whenever failure happens, the WAN service is down. The WAN edge, what it will do, or it will that time it will forward all the received traffic through the other WAN edge using the other WAN edge WAN transport, whatever it is. So this is called as what? TLOC extension.
Sir, that means one edge to one edge should have connectivity, right?
Pardon?
One edge to one edge should have. Right?
That is why you see I have put up a link here. There is a connection between them. We have to make a connection between them. It could be through a switch. It could be direct back-to-back connection between these two WAN edge.
Sir, is it like HSRP, VRRP of traditional WAN?
In HSRP, VRRP, basically what is happening, basically, you see, you know, the virtual IP is same, right?
Yeah, it is same.
That is the gateway. Here it is not like that. This TLOC extension, this VPC, the VPC is always going to see. If you see, I'm not extending this switch to here, basically. For this users and all, here basically their gateway will be always LAVH1. So the traffic will come to LA. It's not like HSRP. In HSRP, when the active router will fail, automatically the standby will take over like that, or the backup router will take over like that. It will basically start receiving the traffic for the same IP. The gateway, default gateway remains same. Here it is not like that. Here router 11 basically will always send the traffic to LAVH2 only. LAVH2 cannot send it forward directly through its WAN service. So it alternatively forward the traffic to LAVH1, and like LAVH1 will forward the traffic further. So they are giving like this backup service. So here in this thing is called as what? TLOC extension. We can even have VRRP also. See, I can have here, if this is a switch. If this is a switch, basically, then we can do basically VRRP. I can provide VRRP also like that. But then that VRRP can be like, not only it will take care of the WAN failure, it will take care of the whole, the whole WAN edge, basically, right?
Yeah.
HSRP, VRRP will provide not only WAN redundancy, right? HSRP, VRRP, they also provide what? The router redundancy.
Yeah, even if the device fails.
The whole device fails, we have the solution. Like that. That is why it is called as what? HSRP, VRRP, they are classified into what category of protocols? Any idea?
Redundancy.
They are called as what? FHRP, first hop redundancy protocols. FHRP, like that. Means the first hop, the router itself can fail. The whole router can fail, still the other router will be able to provide. TLOC extension is not like that. In TLOC extension, see, LA2 is not failing, WAN edge is not failing, WAN service is failing, which is more practical like that. In a real world scenario, routers frequently don't fail, basically. The WAN services will go down, basically. The WAN services usually fail. HSRP is HSRP, VRRP, it's a very comprehensive solution. It takes care of all the possibilities. WAN failure, LAN failure, the whole router failure, like that. Okay. So, but TLOC is not like that. It's not a full WAN edge, this thing, basically. Now, what is the requirement? Coming back to this, and let me clean up the space. So as you can see from the diagram, basically what are required, basically, see, between the two WAN edges, we need to have a dedicated interface. You need to have one dedicated interface which will provide TLOC extension, and you connect this dedicated interface of both the WAN edges to each other together. Basically, it could be through a switch also, it could be directly back-to-back connection. If the two devices are very close, straight away pull a cable between the two devices and connect them. Or if they're not very close, then you can use a switch, and then basically you can do the connection. Doesn't matter, basically.
Sir Kiran, sorry to interrupt. Maybe I'm not sure whether you have covered this. What if the link between LA01 and LA02 down? how the redundancy effects will take care.
Which which
See,
link you are talking about?
yes, the red
This
one.
one, this one,
Yes,
red one.
yes.
This is the link basically which will be normally used only when this WAN services will fail, right? Like that.
No, no, no. I mean, see, from VPC, initially the traffic is going through internet.
Like this. Let's say it is going like
Yes.
this through internet.
Yes. So if
Okay.
LA01 to internet goes down, then it takes the route of
Then LA1 will forward the traffic like this.
because we are setting some priority or some mechanism, right?
Then only it will come to this side like that.
Fine. So if my interlink between LA01 and 02 goes down, so
Then it cannot forward. No,
okay,
then you
okay,
don't have the backup only then.
okay. I got a bit confused with
No,
the
no.
hierarchy concept. Okay, okay.
No,
I
I think here we will have multiple links to, to assure that
you
our
can
backup.
yes, you can have like that multiple links also basically.
But
okay. Now I got it.
but I was thinking I was thinking loud. So these are in different locations, right? These are not this will not be Ethernet, right?
No. These are in the same location, na LA. That is why
Same
physically.
location. No, it is in LA, but do you think they are in the same data center or different data center? Like I am thinking, like, can we implement LA?
No.
But LA city will be Ethernet.
They are in the same, as I said, in the same campus, same building, same data center.
Oh, okay. Then maybe we can implement
you can't have them basically like in LA, but basically this is in one part of the LA and this is in the other part of the LA. No, not like that.
Okay.
Like that. That's the reason I said not direct. They must be like in a close proximity so that you can even have a direct cable connected to them.
Okay.
Like that. It's not like it will not be again you take up some WAN service here between them.
Okay.
Like that. It's not like that.
Yeah, sir. One more thing. Do we have a multiple? Can we have a connection from VPC to LA01 and 02 for redundant purpose?
If you do that, then that can be called as a VRRP then, no?
Okay.
Then that can be done in VRRP. Yes.
So
like traditionally what we do in VRRP, same thing can be done in VRRP.
So here we are taking a risk of like if the link between LA01 and VPC goes down, then it is
why this topology is like that. I said in the very beginning, this basically this VPC basically this is a total different business department of an organization. Sometimes in some organizations some departments work independently, right? Like that. And that's the reason they had their own basically WAN. They had their own WAN service and they also have their own WAN service. Whenever WAN service was failing, these users were complaining to the management that okay, buy one more WAN service basically. But the business volume is just not like that. The commercial, for everything in organization, they always look from the commercial point of view. Is it justifiable to put up one more link basically? To take up a one more link. Maybe here you don't have that many users basically. So company is not ready. It says, okay, whenever WAN service fails, you guys, you enjoy life, maybe half an hour. If this WAN service is down for 1 hour, okay, you go enjoy basically. You can play basically, you can go to the cafeteria, enjoy coffee, tea, or basically, play table tennis like that. People can do whatever like that. Then later on what happened? These guys, these two department, they know, they come to know that hey, there is another vantage also over here like that. And now the people who know this SD-WAN, if they are aware of this T-lock extension, they say, hey, we can now have like this solution. We connect these two vanages back to back like that, and then whenever our WAN service will fail, we'll use the other vantage, other WAN service to send and receive the traffic. Whenever their WAN service fails, they will use our WAN service. So it's like an agreement between these two business departments like that.
Yeah.
Okay.
Got it. Thanks.
Like that. So we have to think of different scenarios. As you said, I could have connected that VPC to LA2 also. I could have put a switch also. In fact, in my topology, there is a switch already there, basically. So VRRP also is another solution for this, basically. Okay. VRRP is a more comprehensive solution. Like normally we do that always, we are aware. But from Cisco Viptela Sdwan, I wanted to it is part of the basically the course content that student must be aware of this solution also, TLOC extension. Okay, clear the reason why like this setup is there, everyone now?
Yeah, in TLOC, then we are giving importance or priority only the redundancy towards the WAN end.
Yes.
Yes. Okay.
Yeah. This feature will itself make it like backup. It will not become like a primary like that. Okay.
Okay.
So
Thanks.
now what is the requirement? As I said, what is the requirement? The requirement is what? You need to have a physical interface. It must be free. It must be unused interface. So if your WAN edge has a spare one interface, you connect that interface of both the WAN edges. And then what is the next requirement? You see the sub interface. That is the reason I said no, that the direct internet access lab will do it later, because here also we have sub interfaces basically. And then the sub interfaces, you assign them to some subnet. So see here, I assigned them to this subnet. I have used another subnet here basically. Again, why I use basically one subnet, I use IP address from basically 10 dot series, and why I use 172, because I need basically over here actually now slide changes, because this is basically 172. It's basically, whereas LA VH1 basically now we are not using private IP, we are using a public IP. So it is basically 180.10. This is the subnet basically which is being used on the internet. MPLS side it is still private IP only, but on the internet side it is public IP. Anyway, that doesn't matter. It's not necessary that this 172 it has to be part of 180 only. So we'll keep this IP addressing whatever is here. Only thing is that internet is not 172.16. Okay, it is basically, in our scenario, it is 180.10 basically .0.0 public IP like that, because internet usually has a public IP. So this will be the IP addresses which will be will be configuring basically, correct? So let us now move how to do this basically. I don't know. Hope the switch is up. So let us go to templates. Now, this is a new template so far. If you see on LAVH1, as per the topology, if I come to LAVH1 or LAVH2, we only configured the WAN side interface, and we only configured the basically the LAN side interface gigabit 0/2, the service VPN side. VPN 0 transport side, we configured the interface gigabit 0/0, and the service VPN 100 side, we configured gigabit 0/2. So if you see, there is a spare interface gigabit 0/1 connecting to basically gigabit 0/1 of LA like that. So this is the new interface basically. So, but the thing is that now this interface will become part of what? Will it be part of service VPN, or will it be part of transport VPN? Guys, see here, see the diagram.
Service VPN, I guess.
Again, let us take this thing. When suppose this is failing, let's say internet is failing. If this internet fails, the traffic is still going to come VPC like that. It comes in VPN 100 like that. But then what will happen? It has to go through where? Basically, it has to go through now LAVH2. So the traffic will come here. So basically, it has to be forwarded from you receive the user traffic in service VPN 100, but you have to forward it to where? To the transport now. Your WAN transport is failing. WAN transport was in which VPN? WAN transport was in which VPN? VPN 0. That means now this link will become part of what? VPN 0. So that means this is basically, this will be like this. VPN 0. It cannot be part of service VPN. Why? Because you can, like I have here VPN 100, I can have another service VPN here. I can have 10 service VPNs here. So it will, this link will become part of which service? No, it cannot become part of service VPN. It will be, it has to be part of the transport, because the traffic, the WAN edge will receive the traffic from any service VPN, but when it has to forward the traffic outside, for outside the transport VPN, it is called as transport VPN, VPN 0. That means this link, this TLOC link, this TLOC extension link will be part of VPN 0. It cannot be part of this thing. So this physical interface, this sub interface, they will be all part of VPN 0, like that. Okay. Clear, guys? So it will be not, this interfaces will not be part of service VPN, because service VPN can be multiple service VPNs. So one interface, you cannot make it part of multiple service VPNs. So basically it will be part of VPN 0, because this is where. So same thing, please understand here, when the traffic, when this fail, when LAVH1 WAN is service failing, basically the traffic will come here. LAVH1 will forward the traffic via its sub interface. That means this through this sub interface, basically, you know, it will basically, the traffic is going to go through the MPLS cloud. That means this sub interface, the traffic has to be basically IPsec. That security responsibility is of LAVH1. It is not responsibility of LAVH2. In case of when internet is failing, LAVH2 is just becoming like a next hop, just becoming like a, you know, forwarding router basically. So the traffic, user traffic security has to be taken care by the WAN edge, which receives that user traffic. So basically this interface also will be like a tunnel. So the tunnel will set up from like this, from here, go to wherever it is the traffic is going, basically. Same way, when this internet is failing, when this MPLS is failing, when this LAVH2 someday receives the traffic, its MPLS has failed, so it will forward the traffic like this through this interface, like that. Then that time this guy also has to take care of what? IPsec. So the interfaces has to be part of basically, you know, the tunnel interface. We have to configure them. Whatever we do, like normally the WAN interface, the VPN 0 interface, whatever configuration we do, same thing we have to do basically here. This interface, and this interface. Not this one and not this one. This will be like normal interfaces, sub interfaces. So please keep a note of this. So first, let us create first a feature template. We'll create a new feature template. I say I want to create a new feature template. It is asking me device, basically. We'll just simply says VH Cloud, and I create a feature template interface type. It's a totally new interface, so we can create a totally new interface feature template. So I say feature template, let's say, again, this will be what? VPN 0 only. So we'll say VPN -0, but we are basically creating what? Interfaces for TLOC extension. So TLOC extension, I just write TLOC ext. So we know that this is a basically interface which will be used gigabit. What is the interface we are using? Gigabit 0/1. Okay, this interface has to be no shutdown. Yes, interface name, which interface I'm going to use? Gigabit 0/1. Okay, then I don't require any IP address. Physical interface will not have any IP address. That's it. like that. So I say save. A very simple feature template. We create VPN 0 gigabit 0/1, that is for the TLOC extension. This feature template we create. Then what we do now? We have to assign this feature template to where VPN 0. Physical interface has to be part of the VPN. But anyway, let us create now the sub interface template. So again, I add sub interface templates. So let us do this VH Cloud. So I'm creating this template first. Let's say we are going to do it for LA VH1. So I say sub interface VPN interface template I'm going to create. Again, I'll write down the same thing, Control V. Basically, I'll say basically VPN. Basically, this is the gigabit 0/1. Meaning that. Now we have to refer our diagram. I'm creating gigabit 0/1 on LA. I'm creating this sub interface for whom? LA. Please keep a note this thing. Okay. So this interface it will be used when gigabit 0/1.1. This sub interface of LA1 will be used by whom? When it will be used? Yes, guys, gigabit 0/1.1. This sub interface will be used when?
When forwarding the service VPN.
No, when LA2 will forward the traffic to this interface. Why LA2 will forward the traffic to this interface? Because its WAN service MPLS has failed. So whenever MPLS is failing, LA2 will forward the traffic, and the packets and the traffic will land on 0/1.1. So in this case, 0/1.1, this sub interface of LA1 will be what? It will be like just like a normal interface. See, it is telling it will be like an extension of this giga. It's written here. It will be like an extension of gigabit 0/0, the main WAN interface. So this sub interface is nothing but an extension. So we are just extending, like, we are extending this gigabit interface like this here. It's as good as it is becoming, like, gigabit 0/0, like that. So that's the reason it is called as TLOC extension of. We have to specify. You are basically here. You are going to act like a TLOC extension of gigabit 0/0. So when I create this interface name, I say it will be gigabit 0/1.1. Yes, it will be gigabit 0/1.1, like that. Then IP address. Yes, it will have an IP address. And now I'll make it. See, this templates, they are not basically will be used later on. If you want, you can make it reusable. But at the moment, let us make it only specific for this particular department or this particular branch. So that's the reason I'll keep it global. Straight away I'll assign the IP address with that. So far we did always device specific. Let's say in this case we are going to do straight away IP address. So I say IP address will be as, what is it? Basically 172.16 dot we'll follow the diagram only, 60.1/30, let's say. So 172.16.60 dot 1/30. Okay. And now we are this interface, as I said, this is going to act as what? It is going to just, it has to forward the traffic. When it receives this, when LA VH1 will receive any traffic on this interface, what it has to do? It has to forward the traffic to its outgoing interface, gigabit 0/1. That means it is becoming like an extension. So that's the reason. Where is this option? We go to the advanced option, advanced menu. When you come here, if you go little slide down, see you have a TLOC extension feature. You have something called as what? TLOC extension. So here we specify global, and I specify, hey, you are will be the TLOC extension of which interface? Gigabit 0/1, the WAN, the actual WAN interface, like that. And then duplex we want, you can keep it full, half, not compulsory. MTU is default 1500. Yes, okay. Like, so I created one interface, basically one sub interface, basically gigabit 0/1. I can make it basically very specific also. Sorry. Sure. This is the one. But again, now this template I cannot make out basically because I made it very specific for LAVH1. So basically, let us give the name that we will know that basically this sub interface templates basically are for LAVH1. And or if I want this to be, later on I want this to be used, as I said, maybe there could be other in scenarios also, some like in a very big environment, thousands of location, like this possibility can be there for some other sites also. So in that case, what I will do basically, I'll say we'll like that, we'll keep it in the WAN service. I will say basically inet, because this is, we are doing it for LAVH1. LAVH1, the internet is what the WAN service is inet, internet service. So we'll keep it like this, so that we'll make out that, oh, basically this is will be for inet services. LAVH1 type of router. Those WANages who have only one WAN service, that is internet. So Control C. Not compulsory, you can give any name, but while creating the templates, it should, later on we should think always like later on, do I want it to be used, do I want it to be reused again and again? So if that is the requirement, then we can make it reusable. And then in that, if you want to reuse it later on, then it can't have IP global, then you have to make it device specific then in that case. But anyway, right now we are keeping it this name. So first interface, sub interface for LAVH1 is created. Now I create another sub interface. Again, I say add interface. Select the interface Ethernet type. We'll give the same name, only I'm going to change. Now again, this is basically, this is going to use now this second, I'm creating second interface for LAVH2 only. Okay, LAVH2 I'm going to use second sub interface. So I'm keeping the, because I'm going to identify the interface by the WAN service. So inet only I'm going to keep it. Let us copy paste this. Again, this interface. Oh, I did not, did I? I'll need to check the earlier sub interface. This shutdown, I did it, no shut or not, I don't know. We'll verify it again. So gigabit 0/1.2 now this time. Then this one also will have an IP address. Yes, I'll keep it for the time being. We're keeping it global. What's the IP address as per the diagram? 10.155.65.1 something like that. This organization is saying I could have done 10.111, but 10.111. Yeah, I can make it 10.111 also. Let us 1 minute. Just hold on. We'll make it. I'll just correct it. So 10.1.111 we'll keep, because LA the site ID is 111, so we'll keep it 111 only. Okay, so we'll keep the IP address. So now saved it. It is 111. So we'll use this IP. So I'll assign 10 dot. What is it was 10 dot no, 111 dot 60, right? It is 65. Okay, 65. That 60, 65, like that, something third octet I have used. So 10.111.65 dot 1/30. Okay, it could have been slash it could be slash 24, anything, whatever. Basically, I kept it just basically it's just a direct point to point link, so I kept it basically slash 30. So 10 dot 111.65.1/30. Looks same. Let me confirm. 10.111.65.1/30. Okay, so we assign, and then where we go, this is a sub interface. So sub interface MTU also we have to reduce. I think this is also I did not do duplex full. MTUs must be reduced. I did not reduce in the first sub in the first one also. Okay, then now will I do TLOC extension here? No, this is not a TLOC extension interface. The second sub interface is not a TLOC extension. Please understand this. Okay. So we have to just sub interface, we have to reduce the MTU. So this is the second sub interface which got created. So first one I missed out some that MTU. So let us go back to this sub interface advanced section. We don't this is a physical interface, yes, but the MTU has to be lower than the default. Otherwise, when we'll configure the when we manage, we'll try to push the configuration. That time error comes, that MTU error comes. So now since we know, we should reduce the sub interface MTU, because cannot have the same MTU as a physical interface, as it will lead to a bigger frame size, which can lead to some fragmentation issues. In fact, it does not allow only. Cisco Viptela SD-WAN does not allow the sub interfaces to have the same MTU as the physical interface. It's a part of the configuration step. So now the two sub interfaces and the physical interface is ready. So what I can do now, I go to the device template for LAVH1 single WAN transport on iNet. Say that is what I'll do now. I'm going to add this thing here. Okay, one more problem is there now. As I said, now see the diagram. See, that's the reason you should have this TLOG extension diagram handy basically. Now what I said basically, when internet fails, LAVH1 is going to use which sub interface? It's 0/1.2 sub interface and forward the traffic. How the traffic will leave LAVH1? Will it leave unencrypted, unsecured? No, it is your traffic coming from your service VPN. It is managed responsibility to take care of its own traffic if it is forwarding outside to any other interface. That means it has to do IPsec. So did I on 0/1.2 this sub interface, did I configure whatever we do normally we configure for the VPN 0 interface? No, I did not configure that part. So again, we have to go back to the feature templates. We go back to the second sub interface. Oh, this switch. So we have to remember this basically. Whenever this WAN service is going to fail, this LAVH1 is going to receive the traffic. It has to forward. It will forward, because this is, I said, this first sub interface. I said you are going to you are an extension of gigabit 0 site. That means you will receive the traffic. You will receive the traffic to send. That means this is basically like an ingress interface. It will always be an ingress. Whereas when you receive traffic from service VPN, you cannot forward it here. This side is failure. You know that you cannot forward it here. You have to forward the traffic here. So now this traffic, this becomes like an egress sub interface. And since it is an egress sub interface or outgoing sub interface, the traffic has to go as what? IPsec. That means this interface now needs what? The tunnel configurations. So that's the reason. Let us refresh this now. Okay, good. Feature template has come. So I go to the second sub interface. Where is it? Second sub interface, this one. We need to edit. So we go to the tunnel feature. Interface is no shut is good. No shutdown. Tunnel interface is off, so I make it global on. Once it becomes on, then normally we'll see which interface it will use now. When this will be an outgoing interface, so it has to use which color? Color will be MPLS, because you are going to use WAN H2, LA2 WAN service. LA2 WAN service is what? MPLS. So I say this thing. Then basically normally what we do, if you remember, we do what? Allow services all, because if your WAN service fails, then how you will maintain your control connections and all. So whatever we do on the physical interface, we have to do allow services all. Allow services netconf also should be allowed. Allow services basically SSH on, like that. I think now this is good. So tunnel interfaces are enabled, and so it becomes encapsulation IPsec, and then basically the services are allowed. Okay. The physical interface also, the first physical interface, I think I did not make it no shut. Let us check it. First sub interface also. There you see shutdown. The physical interface I did no shut, but sub interface is in the shutdown state. So we have to be careful. This is only a TLOC extension interface, so we don't need to do anything else. Just MTU we have to reduce, and we have to specify you are basically connecting to gigabit 0. You are forwarding the traffic to gigabit 0/0. So this looks good. So now the feature templates, the two sub interface templates and the physical interface templates are ready to be integrated in the device template. So now I go to the device template, single WAN transport inet. Over here we go, we say edit. Everything will be in the transport and management VPN section, so we don't need to go into any service VPN side. So I click transport VPN management. Already you see this is what is there, and this is what I was doing for direct internet access gigabit. Now I add here the physical interface first. So I add the physical interface now. Which is the physical interface I want to add? The parent interface, the main interface, physical interface. Then now I have to add the sub interfaces also here. So again I add, and I say I want to add this first tlog extension sub interface gigabit 0/1. Then again one more time I add, select gigabit 0. So interfaces I have added now. Now I say update. We can check basically preview. We'll go to VPN 0 section. VPN 0 originally has this gigabit. So the previous configuration will remain as it is. This is the new green, means which is the new configuration which is getting added. So this is a new interface which is getting added. This is a new interface. It will have this IP address. It is basically a tlog extension of gigabit 0. The first sub interface is tlog extension of gigabit 0/0. It is the no shutdown state good. Like that. Then second sub interface, it will have this IP address. It is basically a tunnel interface because it has to do encapsulation IPsec. It is going to use the WAN service MPLS allow services. So this is also MTU good. So now it looks good basically. If everything goes good for LAVH1, then we create the sub interfaces. Then we create the templates, feature templates for LAVH2. Always try with one manage, don't try to do it together. See now success is there. So LAVH1, all the feature templates what we did got integrated with LAVH1 now. So since this is success, now we go back to the template sections. Okay, now the gig on LAVH2 also, as per the diagram, LAVH2 as per the diagram, what is the physical interface which will be used? LAVH2, the physical interface is also gigabit 0/1. That means I don't need to create a separate physical interface feature template. The same template which I use on LAVH1, I can use it over here also. Then we'll see whether we can use the feature templates which we created for LAVH1. Can they be used for LAVH2? I don't think so it will be used, because here basically if you see it is opposite. Basically on LAVH1, 0/1.1 is the extension of gigabit tlog extension of gigabit 0/0, whereas on LAVH2 it is gigabit 0/1.2, which will be basically extension of gigabit 0/0. I could have made it one here also 0/1.1, and I could have made it 0/1.2 also. But sometimes, as I said, mistakes do happen in the real world. So there can be sometimes design issues. So let's say the design was created by somebody else. It's a wrong design. So you don't have the permission to change it. It will change modify that will require another basically lot of approvals and all. Let us continue with that as it is. So physical interface, I don't need to create a feature template, but for sub interfaces, we can like that. So what we'll do, but again, since this is a software based thing, we will take advantage of what the software features. So I'll pick up the first in sub interface. I'll make a copy of this guy first sub interface. Okay, I'll make a copy. But when I copy this, what I'll do, I'll say, hey, you are copy, but basically the interface number I'll keep it 2. And WAN service is not internet here. So now I know that this is basically for those WAN edges who has MPLS WAN service. So basically I'll say MPLS. Looks good. VPN 0, TLOC extension. MPLS is the WAN service this WAN edge business has. So this template will be used, will be attached to those WAN edges who has MPLS WAN service. And what is this interface? Gigabit 0/1.2. I say copy. So it becomes copy. Instead of we could have defined it totally new. But now we made a copy. Once we make a copy, basically what will happen? It will have all the features of the earlier template. Maybe we have to edit now. So we'll go and edit this. So no shutdown is very good. That is what we wanted. Interface name, see here, it has to be, cannot be gigabit 0/1, it has to be gigabit 0/2. And IP address, it cannot be this, basically as per the diagram. LAVH2, we should check the diagram. LAVH2 gigabit 0/1.2 will have 10.111.65.2/30. So the IP address has, we have to change it. 10.111.65.2/30. Done. Then what next now? Tunnel, it will not be a tunnel, it will be only a TLOC extension. So I go and check here. Yes, it is full duplex, MTU reduced, and it is already TLOC. Is it all on the, again we have to be careful, since I'm making on LAVH1 the WAN interface is gigabit 0/0. How about LAVH2? What is the interface on LAVH2? Is it also gigabit 0/0? Yes, gigabit 0/0. Here also gigabit 0. So this guy is extension of gigabit 0/1.2 is extension of gigabit 0/0. So no need to do anything. Looks good. Again, confirm TLOC extension done. MTU done. Like that. This thing done. Okay. Looks good. IP address 10.1.65.2. Yes, because 65.1 is basically LAVH1. This is 65.2. Looks good. Okay, done. So we have created, actually we have created the second subinterface. Now we have to create the first subinterface again. What we'll do basically, we have inet from, so this is the inet second subinterface. This second subinterface of inet will become the first interface for in this one, LAVH2. So what we'll do, we'll make a copy from here now. Second subinterface, I say copy, and I will make it 1.1 and we'll replace it by MPLS. So it will be 1.1 copy made. We'll go to this thing, copy one. We edit this now because it will have the other values. See, it has basically 1.2. So I'll say, no, you are not 1.2, you are basically 1.1, because on LAVH2, you are basically 1.1. You are in no shutdown state. IP address cannot be now 170 here. Here it will be 172.16. I think it is 60.2/30. Let me confirm. 172.16.60.20/30 Okay. So 172.16.60.20. Yes. Interface name, I have corrected it. Then tunnel, it will have all this. See, I don't need to do anything because I made a copy, so everything is already done. Here one change has to be there. When LAVH2 is going to send the traffic via LAVH1 WAN service is not MPLS. LAVH1 WAN service is what? Color is business internet. So I have to change it here. And one more optional setting is there. Not needed. Let us keep it as it is. Let us update it and let's see it works. So this is color, very important. LA for LAVH2. This backup will use, because primary is MPLS and MPLS primary fails, so backup will be what? Business internet. So that's the reason I'm putting business internet here. So now the two feature templates for LAVH2 is also ready, like that, to be integrated. We go to the device template now. Device template single WAN transport MPLS, that is LAVH2. We go and I say I want to add the new feature templates, where we'll add in transport VPN 0 section. Transport VPN 0 already has this some interfaces basically here, like that. Now we add what here? Basically we say we want to add one more interface. First we'll add the physical interface. So physical interface remains same. This is the same thing, it will be there. Then I will say I want to add sub interface. Which one? I'm adding MPLS 0/1.1 and basically one more MPLS 0/1.2. We already provided the values. Straight away configure. Success. So now this thing is, so this thing has been basically, the templates have been integrated. Now we need to do testing purpose, right? Testing. So what we can do, do I need to CLI? No, we can go through network monitor also. Network monitor, basically LAVH1. Let's go to LAVH1. Troubleshooting. You see, we have ping option here also. Directly from here also I can do ping. Destination IP. I am on LAVH1. LAVH1. My IP basically is 170. Destination will, I say I want to test 172.16.60.2 in VPN 0. Which interface I want to use? It is showing me these are my interfaces. So I have to say I want to use this 172.16.60 because I'm pinging 60.2. Ping, let's see, ping works. Yes, first, because of our resolution, first packet failed, but we see packets received. So 80% is the success. Yes. So this is working. I'll test the other one also. The other IP is 10.111.65. Again, I have to from LA, I have to ping .2 IP, and this time the interface has to be this one, 10.111.65.1. I say okay, ping, show me this one. So this is also working. Now you see, that means the sub interface, the sub interface links are up. So same thing. See, this is the same thing, physical interface. You just create sub interface. I don't know why it was not working for gigabit 0/2. Anyone will troubleshoot this thing. Let us complete this now. So now the links are up now. Now the links are up basically. Okay. In there. We have done this now. We have to now think from the routing point of view now. Now we have to think from routing. Let us see the diagram. Okay, let us see the diagram. This TLOC extensions configurations we have done now. Now the thing is that when VPC sends the traffic to LAVH1, once the traffic comes to LAVH1, LAVH1 has to forward the traffic to, it will forward the traffic to INET. So normally it should go this way. Okay, so let us do this thing now. VPC, the gateway is same LA VH2, but now VH1 I have to do the changes. Templates, device template. Right now, what we are configuring is TLOG. So what I'm going to do basically for the internet, basically this device template, complete this device template, I'm going to make a copy. Okay, I'm going to make a copy, complete device template. I say copy, and I'm going to name it basically TLOG. TLOG extension device template. I'll make a copy so that later on I can revert back to the old one. Control C. So single transport normal right now. This is one is there. What I do, I move this now from here. So I'll say attach. No, I'll edit this first and then I'll attach. So I'll edit this. Because if you remember yesterday for direct internet, I created that sub interfaces and all basically. So we don't want that basically. Transport VPN. I go here. I don't need this one because now direct internet will do it. The other one. This is basically for TLOG extension lab we are doing. So VPN 0, gigabit 0/1. The two sub interfaces are there. This is good. Service VPN side, basically this sub interfaces I don't need basically. Instead I will add a sub in the normal sub interface. What was the normal sub interface? Gigabit 0/2 VPN 100 interface feature template.
So, sir, are we just mapping our service in VPN into the TLOG extension now?
No. See what has happened. If you see, for my direct internet access, right? We had created two VLANs and all. Correct here, like that. For direct internet access, I wanted that VPC and this router 11. They should all forward the traffic via VH1, right? Two different segments I said, but we want to give internet access to only one segment. That was the lab we were doing yesterday, which we were not able to complete, right? But as I said, now we'll come back to that one later. We'll do this TLOG extension first. So now if I do with the existing device template, if I attach this device template, then we cannot have this thing. In case of TLOG extensions in lab, basically what we see, VPC has nothing to do with LA2, and if you see R11 has nothing to do with LA1. R11 gateway should be what? R11 gateway should be what? LA2. VPC gateway should be what? LA1. VPC gateway is already available. But what is the here? Am I using sub interface on LAVH2? No, I'm using basically physical interface in TLOG extension, gigabit 0/2. So that's the reason what I did. Whatever I configured that feature template right now, this device template, whatever was there, single internet as it is, it has all the features. I just made a copy of that device template, so that it will have everything. Now in this TLOC extension lab, what I did, I modified TLOC extension lab. I removed the feature templates and added the new feature templates. So now I will move this LAVH1 from this featured device, from this device template. I'm going to move, because if you see here device is 0. Device template without any devices attached is useless. So what I say now, I say attach devices. So which device I will attach? LAVH1. LAVH1 currently is part of some other device template. I'm saying no, you get attached to this one now. What will happen? It will leave that template and now it will become part of this template. We have to provide now definitely some values. So what are the values? It is saying, okay, give me the IP address, IPv4 address. See, now it is asking only IP address for gigabit 0/2. Gigabit 0/2, what is the IP address? It has to be 10.0.1.151.151.151/24. Updated, only one change. Now VPC should be able to, we should have VPC gateway will become LAVH1, like that. So this is done now. Now again come back to this diagram. Physically, see this diagram. We see that VPC basically is connected via like this some switch to LA, but LA in this diagram you see R11 I'm showing directly connected to LA, but actually in reality it is not like that. Like in reality here it is what basically, here basically we have what, a switch, right? This is basically they are connected like this via switch. This is our switch 111. Basically this is the switch here. So now, but the thing is that now this has to be a different segment. This, if you remember, I put it in what? In VLAN 10. And this interface also I put it in what? Yes, guys, I put into what? VLAN 20, correct? So I'm not changing all this thing. But the thing is that now I want R11 only should have gateway pointing to LAVH2. So that's the reason this interface also has to be part of VLAN 20. Same thing, this interface also has to be part of VLAN 20. So on the switch also I have to do this change. For LA1, I think it is 0/ I don't know what is it. What is the diagram? Zero slash 0/2. 0/0/2. So basically 0/0/, and this is basically 0. No, this is 0/1. Sorry, 0/1, 0/2. This is basically 0/0. This was basically 0/3. So 0/0 is part of VLAN 10, 0/3 is part of VLAN 20. So 0/2 also has to be part of VLAN 20 on the switch, and 0/1 has to be part of VLAN 10. Let us go here. I go where? To the switch now. Show run interface Ethernet 0/0. It is showing CV VLAN 10, and 0/3 it is showing VLAN 20. Okay, so now I go to interface config mode. I say interface E0/1. I say you will be default it basically. First of all, 0/1 switch port mode access VLAN 10 and do show run interface E0/2. I already kept it in VLAN 20. So this is for LAVH2 side. This switch is good now as of now. Okay. So now can I do the testing? Let us see. VPC should be able to ping now gateway. Ping Z10.0.111. No, not 254. It is 151. LAVH1 IP is 151, 10.0.1. And then you see. So now VPC is able to go through LAVH2. VPC is able to go to LAVH2. Can it access basically data center? This user will be able to access a server in return. Yes. So see, this is going now through internet at the moment. How about router 11? Router 11, as I said, router 11 also I made it as what? Like basically I made it like a what I made? Router 11, I made it as what? Like a host yesterday, if you remember. So I provided gateway. I don't know what is the gateway I provided. Let us see the gateway IP on router 11. Default gateway is 10.0.20.151. So that means now LAVH to this interface, LAVH to this interface IP. This IP has to be 10.0.20.1, since it is second manage 152/24 like that. So this will be going like this, and then this guy is going to go like this. This is what it is. So normally when this goes, it will go like this, like that. But if this fails, that is where basically the traffic like this will come and it has to go this way. This is what we want. And when this guy fails, the traffic will come and go like this. So this is what we are trying to do now. Now LAVH1 is ready with everything now. As of now, LAVH1 is ready. Let us go to LAVH2. Oh. We go to the configuration template section. LAVH2 basically is where single transport, single WAN transport MPLS. This is where LAVH2 is there. LAVH2, let us go to this one. Let us see what is it in service VPN side. Service VPN side, we basically it has some OSPF and it has this interface thing like that. So VPN, I don't know what is the this is the interface VPN 100 interface template. This thing is there. Okay. Okay, it looks, yes, VPN interface template is there, but it should have an IP address. We need to change that IP address. So instead of this here, what I do, I cancel, I select the, and I say change value. See, you have option for changing device values. So we'll see, edit. We'll see what is the IP address. See, this is where the problem is there. VPN 100 gigabit 0/. So IP address have given 10.0.111. No, it cannot be 111. We have to make it, correct it to 10. 10.0.20.152/24. This will be the IP address of this guy, like that. So this thing done. In the meantime, I'll come to router 11. Router 11 is showing 151. 151 is not good. IP default gateway 10.0.20.151. Remove the old one. 152. Now let us do a ping and see, is R11 able to ping 10.0.20.152, that is LAVH2. And there you see now this is also done. R11 is able to access R11. For R11 is the gateway, like that. So can R11 also go and access data center resources? Yes, R11 also can go. So now right now, how it is going? It is going basically, if I do a trace, I say trace 192.168.12.12 numeric. It is telling it is going through VH2, LAVH2.
So what is that numeric used for?
See, if you do only just tell it trace an IP address, na? Without numeric, what we'll do, it takes a lot of time. See now, I'll show you. I'll remove the numeric to trace. See, it takes time. When you put numeric, the output comes, trace output comes fast.
Okay, this is really helpful for me.
Yeah, see it now. Normal trace taking so much time. You know, we sometimes do like this. We feel bored, right? The output is coming so slow.
Yes, sir. Yes, sir. This is helpful. Yes.
So like that, you know, numeric. Okay, remember this numeric. Meaning that. Okay, one more thing, guys. Do you know, like on a traditional normal router, like if I do ping, basically, can ping show me the path of the traffic going and coming back? Can ping show me if I do from a Cisco router, if I do a ping to a particular destination, can I see how the traffic flows, how the traffic has gone through and had come back?
No, sir.
No, right? No. If I want to see how the traffic is flowing from particular source to a particular destination, what we do? Trace, correct?
Yes.
So ping does not show me, but trace shows me. But trace also shows what? Only one way, right? It is showing only one way.
Right.
Right? Now see what I'm going to show you guys. I said ping, IP, target IP, same IP 192.168.12.2. This is called as extended ping. Repeat count, let me make it couple of packets is datagram default, timeout default, extended command. I say yes. Now source interface, I can specify my own interface or IP address. I'll keep it my outgoing interface 10.0.20. I don't know what is my IP address. On this router, what is my IP address? Anywhere. IP address is what? No, this is showing the old one. Just now I assigned IP address, correct? Okay, no problem. Instead of, I don't want to waste time, we'll type Ethernet 0/0 that I know. type of service those div. No, I don't want to do set the div, don't fragment bit. Validate reply, I answer, I say yes, I want to validate, and data pattern. And now here I use record, I say record option, I say R for record, number of hops, leave it, enter. Oh my, this thing, you know, our WAN edges, because of security, they are not allowing this thing to work. But if you do like this, no, it will show you, you know, hop by hop IP addresses. Going also, echo request, going also, and echo reply also, it will show you. So one single command with ping, I can know how, whether it is symmetric routing is happening or whether it is asymmetric routing happening. Like that.
This
cannot-
is the best thing, sir. I have got throughout the classes. I can use this in my day-to-day life. Yeah.
Okay, remember, just you type, because now this is SD.
So basically, this will show the return traffic also. Through
Yes,
the...
yes.
Okay, okay.
Yes,
Great,
it shows like that.
Thank you, sir.
So this is one more useful utility for day-to-day troubleshooting. Coming back to, so now what is the scenario? This guy VPC can go through LA VH2, it can go and access the enterprise in resources. Router 11 can go through the enterprise resources. Now we will initiate the failure. Let us go back to router 11. Okay, router 11, let me do a normal ping. I'm doing normal ping, repeat count, I'm going to say, let's say 1000 by that time. No, okay, yeah, let us keep it 100, and I'm going to go to the MPLS routers. Okay, I'm going to go to the MPLS router over here. We have to do the failure on the MPLS router. WAN is going to fail now for this guy. So which is that interface of MPLS router connecting to LAVH2 Ethernet 1/2. MPLS router INTE 1/2, and we have to do this shutdown. Okay, so we keep this here. I come here, and now I'm going to say repeat count. I'm going to do ping, and I keep the command here, shut ready. Okay, come here, I say ping. R11 previously it was pinging, no? Trace.
Repeat count, just increase it, sir.
Let me again bring it up. Let us keep this thing up first. BGP neighborship is also there. BGP neighborship has come up. Okay, see, normal ping is working. Okay. So normal ping is working again, and let me do this thing. In the meantime, let us keep this shut down.
Sir, repeat count, you increase it a little bit.
No, it doesn't matter. No? I'm going to do a failure. Pinging, shut. See, so only 10-15 packets got forwarded, and after that failure happened. So now, is it going through the backup now? See, initially RTO happened, then now it is like host unreachable. U message is coming, host unreachable. R1 is getting host unreachable. Why? Because when you get a host unreachable message, who sends these U messages? The next hop. So R11 is getting these messages from where? R11 is getting these messages from LAVH2. LAVH2 is sending when I'm doing this ping now. When I'm doing this ping from this guy. When I'm sending this ping, the packet is going like this, but now this has failed now. Since it has failed now, okay, it has failed now. What happens now? LAVH2 has gone, lost reachability to everywhere now. It does not have anything. It has this TLOC extension. This link is up. But how my LAVH2 knows that, okay, if this thing fails, it has to forward the traffic here. It has to forward the traffic here. It doesn't know. That's the reason LAVH2 itself does not know 192.160 data center. So he's sending what? Here, destination host unreachable. New messages are coming like that. So that means now what is the next thing we have to take care? We have to take care of what? The routing. We have to teach LAVH2. Hey, normally through BGP, you are going to go use this cloud and send the traffic received from your service VPNs. But when your BGP is failed, when your WAN has failed, that time you use this default route and forward all the traffic to your next stop. Who will be your next stop? This LAVH2. So from this diagram, I have to tell, hey, LAVH2 will be your gateway. What will be your next stop? 172.16.60.1. 172.16.60.1 will be your IP address. You have to forward the traffic over here to this guy, 172.16. This one, 60.1, you have to forward the traffic because you have lost your MPLS service. So this, we have to put a default route here now, like that. But now the question is, now you see here, through MPLS only, this guy, as far as LAVH2 is concerned, it is through MPLS only, it is connecting to where? Through MPLS only, it is connecting to these controllers, right? VM, vSmart, and vBond, right? Like that. But now its MPLS has failed. If the WAN fails, VPN 0 transport fails, what will happen? Will it have the control connections to the servers? Will it have control connections to the servers? No, it will not have control connections now. This guy has gone isolated actually, it has gone isolated now. Like this. It has become isolated. We will see now. If I come here, if we go to vManage, if we go to dashboard, it will show now LAVH2 basically down. Should show, see, immediately it is showing LAVH2 gone, control connection gone. All the control connections gone basically for LAVH1. Because isolated, it does not know. No, through MPLS only, it does not have a backup. So now what to do? Let us make it, let us bring in, first of all, let us bring normal. So again, make it no shutdown. Once WAN service is restored, what will happen? LAVH1 will form, sorry, not LAVH1, LAVH2 will form BGP neighborship with MPLS, and then its underlay will be up. And once it underlay is up, now it will be able to reach the controllers. And once it is able to reach the controllers, then it will be basically, again, we should see here, it should now show, reflect. If I change this, it should come again, dashboard should show C6 up. Now it is again up. Now we have to add a route. Basically, we have to add now a static route. Now, where do we add a static route? We go to the templates. I go to LAVH2 MPLS. Okay, static routes are basically where they don't have a separate feature template. They are part of the VPN feature template. So let us see here now. Edit, transport and VPN section. What is the interface? Basically, we are using MPLS router. I have to add a route, which is the feature template we are using. This is the feature template I'm using, VPN 0 feature template MPLS. This is the template. Here, basically, I have to add a static route like that. This is basically BGP template, which is used for the underlay. This is the interface template, which is used for the MPLS. And this is the VPN 0 template. So this is VPN 0 feature template MPLS. So this we have to see now. In this feature template, we have to add. So I say feature template. Just I don't know so many. I'll just search MPLS. Say show me MPLS. So here it is showing VPN 0 feature template. I shall edit. So you see, by it is not having any static route. Why? Because in case of MPLS cloud, the WAN service is MPLS and the routing is basically not static or default. The routing is what? BGP, and for BGP we have separate template, but now this is a backup. So for backup, now I'm going to add this basically a route here. In this VPN 0 template, I have to specify a route. I'll say specify route. I say, hey, you want to go anywhere. Okay, add gateway next stop. To add the next stop IP, who will be the next stop IP as per the diagram. Next stop IP will be 172.16.60.1. This will be your next stop. So I'll say 172.16.60.1. See, first we have to set up the connection, physical connectivity we established, creating sub interfaces and all. Now we have to take care of the routing issues also. So add this next stop, add this route. So now we have this route now. Now I say update. So now an alternate path is there. So when MPLS will fail, it has this path now. Backup routing. Because LAVH2 was giving a destination host unreachable message to router 11. Let us see on router 11 right now what scenario is there. Ping, let us see ping. Ping right now is working because MPLS is right now working. MPLS is working. Okay, MPLS is working right now. Good. Let us again do a failure. MPLS router failure will do. We'll keep a shutdown. Let's see now this time what happens. Reachability is there again or not. I'm going to shut down again. I bring up the ping, start the ping, and after some time we'll do a failure. Ping has failed. Now let's see what happens. It is still sending. RTOs is happening. It is timing out. And now you see. Now see how the traffic is going. MPLS has failed here. LA2 has failed. LA2 primary WAN service has failed. What it is doing? It is forwarding the traffic to LA VH1, and VH1, like a normal router, like a forwarding device, it forwards any received traffic, check its own routing table and forwards the packet further, like that. Can we test this instead of doing the, can we test this from my vManage itself? Yes, monitor. Let us go to the network option. We'll select the device LAVH. Where is LAVH2? Over here, LAVH2 troubleshooting section. I'll go. I'll say simulate flows. We'll say VPN 0. No, I'll say service VPN 100. What is the interface? Gigabit 0/2. Destination, I say 192.168.12.1. Yes, see, it says it will go. And now you see LAVH2 does not have business internet connectivity. It does have WAN service is what? What is the WAN service for LAVH2? MPLS. But you see here, it is using which color? It is using which service? Business internet. And it is going, sending the traffic to data center has two WAN service. This thing, that's the reason it is showing DC1 as well as DC2. DC1, this is DC1, DC2. See the backup.
So can you show the
Okay.
dashboard, please?
Now, 1 second. When again, let's say now we are going to again, I make the MPLS router again, the WAN service is restored. 1 minute, we'll show you, don't worry. Let us make it normal now. So MPLS interface is coming up. Once MPLS interface comes up, MPLS router will form BGP neighborship. See, BGP neighborship is getting this thing. Neighborship is up and all. Let us do now. Now things are normal. Again, I say troubleshooting. I say I want to do troubleshooting, simulate flows. Again, I say VPN 100 interfaces, destination. I say same IP, simulate flow. Now see what it should show. And now you see it is showing it has two equal path. Now it will say, it is telling it can go through when it, see by default it will always happen ECNP by default. See now MPLS also it is showing and internet also it is showing. So this backup actually results into what? Equal cost multipath. When both the paths are there, traffic will flow through both the links. So your both the WAN services are being optimally utilized. If MPLS fails, then it will go through the business internet. If business internet is failing, anyhow it will go through its own WAN service MPLS. Like that. Okay, now LAVH2 thing has resolved now. Let us now do the LAVH1. You were saying dashboard. Okay, let me go to the dashboard. Somebody said to see dashboard. Okay, what? See the dashboard. What is your query?
No, actually the link between MPLS to LA02, it was shut down, right? Like that time I want to see the dashboard.
Okay, 1 sec. Oh, just give me 1 minute, one phone call.
Yeah. So are you talking like I'm not able to hear you?
So I have shut down this. You wanted to see
Yeah.
the dashboard. Dashboard
yeah.
won't reflect also anything.
That is what I wanted.
Yeah,
So,
because it has an alternate path, na?
yes.
Like that. It has already both the paths. Any one path it can take now.
Okay. So that interface, any warning also will not be there. Huh?
No, nothing.
Okay.
Okay, let's in a traditional WAN, when you have two routers running OSPF. Okay, let's take example. You have two routers running OSPF. Traditional WAN routers. Okay, like that. If one OSPF neighbor goes down, when the other neighbor will come to know the neighbor has gone down, when the other neighbor will come to know, when the dead timer expires, correct?
Mhm.
What are the default dead timer values? 10 and 40. That means after 40 seconds, OSPF will come to know that its neighbor is down. Neighbor is no longer reachable, correct?
Yeah.
Like that. Isn't it too, it's too high, too late in today's fast network? You know, learning about a neighbor going down after 40 seconds is too high
Yes.
basically in today's
Yes.
fast network. So how
Yes.
we can make it fast? What people do? We manipulate the timers.
Yes.
I can make hello time basically. I can keep it hello time, let's say 10 second only. I can say dead interval, I can lower it to maybe 20 second. But even 20 second also is too high basically. Suppose the link between two OSPF routers, if the link fails, we know the link has failed basically. I have basically two routers. They're connected through a link like this.
Mhm.
This link has failed, right? Automatically. Now
Yes.
OSPF routing protocol, or let's say EIGRP is there, or any protocol routing protocol is there. They will detect only when their hold time or when their basically dead interval expires, correct?
Correct.
By lowering the timers, we can speed up this detection, right? But
We
how
can
much?
do BFD also, no?
That is what exactly I was coming to. We have an option today which is called as what? BFD, by directional forwarding detection, correct?
Yes.
Like that. So this feature is enabled by default in Cisco Viptel Sdwan Fabric.
Okay. Okay.
I was just so this guys, whenever link goes down, it will immediately detect a failure.
Got it. Got it.
That is what I was coming to. So BFD is also there already here, guys. Please remember this. It is taking advantage of this very beautiful feature, BFD, like that. And BFD basically you guys, if you have configured, you might be knowing we can set in milliseconds, right? Detections. It can detect in millisecond, 100 millisecond, 200, 300 milliseconds.
And sir, does this have an option for one arm BFD also?
One
Arm BFD. ARM. One arm.
we have to see all BFD is like inbuilt, like, so let me see, let us check. Where will I find this information? BFD, we have to go to the template sections. If you remember, I said when you go to feature template, it shows on the feature template which type of feature template, the one which we created. So you have, as I said, there are something default templates, right? So you have these are the default feature templates. Over here you see BFD. See here, BFD template is there. So we can see this BFD template, what options are available. See the polling interval. Like they did like 60 second. One is like 60,000 millisecond. Like that polling interval is there basically. So if I want to alter this configuration, basically what I can do, I cannot, the default templates we cannot manipulate, correct? What I can do, I'll make a copy of this template and I can customize it, right?
Yes.
Like that. And then I can tell my zip factory default is there basically, already it is using basically. So this BFD template, it can allow us to set whatever value we want basically. We can make it whatever you want to set. So not much features are available, but at least that polling interval you can manipulate, and multiplier value, whatever the polling interval, multiplier 2 times, 3 times, we can set it, or 1 time, 2 time, you can keep it like that. So we have an option for copy. So BFD is also here already there inbuilt, and it is basically part of our device templates. So if I go to like any device template now, let us take basically any one device template, let's say this one, I say view. So you see basic system template. See BFD template is already there by default.
Okay. Thanks.
Yeah. So BFD is also there to take care of fast detection of neighbor detections. Okay.
Sir, can we have few minutes break, sir.
Yeah, I think so. We'll need definitely.
Yeah, that after that only one lab is remaining, right?
Ha, yes.
Yeah, yeah.
Sir, what break we are taking?
Just 5 minutes break.
Okay, okay.
Then
Okay.
we'll resume this now. Okay.
Sir, please stop the recording. Sir, please stop the recording.
Guys. Now, by the time you guys went for this thing for a short break, basically what I did basically here, if you see, I added actually one more, link, connected one more interface, physical interface, that is gigabit 0/3 to the switch basically, because for that direct internet access we have to use that. But before I do that, let us do for see now LAVH2 has a backup working, correct? MPLS is failing, the traffic is going via LAVH1. But what about LAVH1? If LAVH1 internet is failing, then what happens? So let us test that. We go to VPC. I am sending ping basically. Do we have options? How many count? Yes, count is there. Default is 5. So from here also we can do pings minus C. And then basically let's say what about 10? So it is sending 10, should send 10 pings. Yes, it is sending 10 pings. Good. Yeah. So this is also working. So now let us, MPLS is done. We go to the INET router. Where is my INET router? And where is that? What is the connect interface on INET router? It is E0/2. So we'll fail this E0/2 on the INET router and see what happens. Right now internet is working, the traffic is going directly in that through the VPC. So no, INET router. Where is INET router? Interface E0/2. This is the interface we have to shut down. So I'm doing ping from VPC. Okay, up arrow. I start the ping. Ping is going on. Now I come here to INET router and I fail the internet. So INET router failing. See, it is timing out basically. Now same thing with LAVH1 also. When LAVH1 primary thing is not working, the internet is not working, it does not know that it has to forward the traffic to where? It has to forward the traffic to where? To the next router. Next stop will be what? MPLS router, LAVH2 router, it has to forward. So we need to do what? Put a default, one more default routing, static default route for LAVH2. By default, this is the one. I say, hey, if this thing goes down, you can go through this one. So how we can do that? We have to go. What has happened? Oh, see. Problem is there in the EVNG, because if you see this switch continuously run, does never gives any problems. This switch also continuously runs, never gives any problem, but this switch is giving some problem. I don't know. Somebody will say maybe they don't look similar, but well, it's only the matter of, I think, the icon like that image. I think iOS image is same. everything had gone down. Let's see now. Refresh. vSmart is also showing down. Let the fabric come back again. Everything should get. Yeah, vSmart is up. And now since we have done down internet, we should see only why two vantages are showing down. What the two vantage? One LAVH1, LAVH1 should show, LAVH2 also showing down, unreachable. Because it is establishing through the internet also. LAVH2 is having also connection through this one, internet now. So that's the reason it is showing. But anyways, so we see that whenever this internet has gone down, basically LAVH2 users, they cannot access the company resources, right? Right now, if I do this thing, and where is my internet router? Here, it's not working. I do no shut. I bring this internet again up. Once I bring the internet up, there you see, now the user is able to access the resources in the data center reachability. So once the internet comes up and all, within a matter of seconds, it is able to restore the connections with that. So now we have to go to vManage. We'll go to the template section again. We go to device template for single transport inet. We check what is the if you want to add a static default route, there is no separate template. It is basically in the VPN template itself. So if I go to the transport and VPN section, this is the VPN 0 feature template which is being used. Basically, this is the VPN template which is being used, like that, right? So we have to edit this feature template. So I cancel this. We go to the feature template, VPN 0 feature template. It is like a common feature template, I think. VPN 0. This is the template, but this template, if you see, it is being used by everybody. So if I add here a static route, if I add here a static default route, then it will get updated to everyone. Everyone does not need this. So what I have to do, basically, we have to make a copy of this template. And basically we can write it. Basically, this is basically we are using for TLOC extension feature. So we'll work with this TLOC VPN 0 feature template. We edit. I go here inside in the IPv4 route section. We go to the IPv4. There will be already one static default route now. See, it has already one default static route, like that. We add one more now. I say 0.0.0.0/0 gateway. I add next hop, and next hop now has to be as per the diagram. Where is the diagram? It has to be 10.111.65.2. Hey, inet router, if your internet fails, WAN service fails, you have to forward send the traffic to this guy, 10.111.65.2. So I have to specify here gateway 10.111.65.2. And suppose now here, see, we have option here, see distance. If I don't keep distance, what happens? It is same. If it is distance is same for this route also, and the other distance is same for the other route also, what will happen? Equal cost. But maybe let's say I want this to be used basically, as a backup. So I can increase the administrative distance. Let us keep it 10. And we'll add this one I say add one more this default route. So now there are two default routes basically. Okay, they have one next stop, and now I say update. Yeah, see now whenever we want to add two default static routes, no, you cannot do like this. See, it is telling you saying duplicate value, same default route you cannot add like this, even though next stop is same and all. So what I have to do now, I don't know which one is it, which is the one. Let us see it, the first one. Let's see, this is one. What is it? What is its next stop? What is the next stop I have given? This is the new one, no? So this is the new one. I cancel this. Let's say we delete this. So you cannot add multiple default route like this. Okay, how I have to do? I have to go edit the existing default route. I say edit. Okay, I go to this default next stop, and you see I can add one more next stop. See, originally it has this next stop, VPN 0, gateway IP address, administrative distance is 1. So I say I want to add one more next stop. Over here I have to do 10.111. It was what, 65.2. And as I said, I don't want it to be equal cost, so I will make the administrative distance higher, so it will become like a floating static route. Now I say update. Should not be a problem now. So now our LAVH2 also has its primary internet connection, and now we are teaching it. If your primary internet connection is failing, you have an alternate default routing. You have to push all your traffic from your service VPNs to LAVH2. You have a new gateway done. But then now we need to edit the device template for LAVH1 single transport here, because it has the VPN 0 template, the original one, which has only one. So I go to transport VPN section. I say I don't want to use this original. I want to use this TLog extension, because it has now two static default routes with two separate next stops. So see, routing has to be taken care of. So now device template has been did I edit? Then why it is not pushing it? Oh, sorry, it is here. I should add it here basically in this TLog extension, single WAN transport. This is where, sorry. That is why I'm saying why it is not happening. Because it should send the configuration to LAVH1 configure. The new configuration has to be pushed. In the meantime, let us get back our iNet router. Let us get back our testing router. Testing will be what? VPC. And testing will be here. Success. Normal. Now let's see first normal. Normal, when I do this ping, normal ping, it is working. Okay, like that. Now I go to the iNet router. I fail. What is this? iNet router. I'm going to fail with 10 service counts. Start. Shut down. Failure happened. Let's see now. The traffic gets rerouted through MPLS. So you see, for LAVH2, it's not working now. When the internet has gone down, it is still not working. Why it is not? Let us study the diagram. So this is failing. When this fails, this guy, if it sends the traffic, it comes to here. I'm telling, hey, LAVH1, you have to forward the traffic to this guy. This default route has failed. Now, do you have this default route? Yes, this is default route is there now with you. So you forward the traffic to this guy. But the thing is that, we are failing. I'm doing the failure this side, right? I'm failing this interface. What will happen here? Basically, this interface will be up only. So LAVH1 routing table will always show, because I have made this administrative default route to this administrative distance as 1, whereas this administrative distance is what? This is static. This is a floating static route. Floating static route appears in the routing table only when the primary route is not there. That is the reason. So I think we should not have done that thing. LAVH1, if I do right now, I say show me the routing table, IP route for VPN 0. So VPN 0, it has lost the route basically. See, there is no route only for VPN 0. There is no default route. If I come here, if I bring it, make it back, interface is up. Ping should start working. User, yes, user is going through. Routing table, what we get? LAVH2. There you see a default route has come pointing to this. So this default route is coming. If I do show run VPN 0, see this is the administrative distance we have gained higher, so it is not appearing. It's not, when this is failing, this next stop is failing, it's not basically removing it's removing the route, but it's not installing this route. Oh, IP address wrong. See, 10.111.62.5. Wrong configuration I did, guys. Where is it? Feature template. VPN 0 TLOC feature template. Gateway, I added wrong gateway IP address. See, 62. It should have been 65. Corrected. Configuration is corrected. Again, testing. VPC, inet, VPC right now traffic is flowing like that. I come to inet, shutdown, failure. Still not flowing. So see, even though this is it is failing, still not happening basically. If I go to the LAVH2, if I say show again, show IP route VPN 0, let's see. So you see it has these two diff static routes. So this is also there now. This is there and this is also there. Gigabit static route is there. That means now it's not a routing issue now. It is forwarding the traffic. Okay. So LAVH2 says that this is, I have basically two gateway. If this is not available, then I have this one also. Like that. I can send the traffic via this way also. Then why it is not happening? So now the question is, let us go here, dashboard, and let's see what happens when the failure is there. And there you see, that is what I was thinking. The failure is happened. Internet has failed for LAVH1, and you see LAVH1 now is not reachable to the things. Now the question is, why like this? Why it is happening like this? Let us see this now. See, let us analyze this. This is our controllers. Let's take only one controller example case. This is our controller, right? He is connected to what? To a switch. Like that. From the switch, he is connected to inet router, right? And he is connected to what? MPLS also, like this, in single interface, like this. When let's say this is LAVH1, LAVH1 does not have any connectivity to the MPLS. LAVH1, LA1 has only one. This is, what is the IP here? IP is 180, belongs to 180.10
Sorry
subnet.
to
Hello?
Sir, this one, actually, when I asked to show the dashboard, after making the interface down from MPLS to LA2, I think, was it brought back?
Yeah, MPLS is brought back, I think. This is it is showing because it is going through internet also. Now if I make internet up now, see, hold on, just let me show you quickly. I'll go to inet router. I'll make interface again up. Now MPLS is also up, and inet is let me, as you said, let me check, confirm. MPLS, we are down. I don't know, show IP interface brief. Oh, it is down here.
Yeah, that is why the problem.
Oh, okay, you are right. Interface E1/2. We just checked the redundancy backup happening on MPLS LAVH2, but
Yes.
we did not restore it.
Yes,
You are
yes,
right.
yes.
Okay, right. You're right. So better to have this thing. Let us make it now. Now internet is also up. MPLS is also up. Let us refresh here. Let's see the dashboard. See, now everything is showing up now. Okay. So this is all normal. So in this case, basically, that is what I was coming, like when this is going to fail, this LA, we are telling, hey, LA, you have to forward the traffic. LA, you have another guy, LA2. LA2 has an MPLS connection. So when internet is failing for you, LA2, you have to forward the traffic to this guy. And this guy basically already it has basically reachability, so it is going to act like a normal router. But so MPLS router, the interface was shut down. So we have analyzed this. Now we now the problem is what? Okay, good, everything is good. So let us do again a testing inet router and VPC. Shutdown command ready. I say up arrow, ping 10 packets. Come here. I'll make the interface down. Lost internet. LAVH2 has lost internet. Is having a default route. Another place it is no, still not working. Destination network unreachable. So LAVH2 now does not know. And you see here dashboard, it is showing LAVH2. See, gone. WAN edge has gone down. Why? Why? Now the problem is there. See the thing. Okay. Let us study this now. See, when LAV, let's say this internet is down. Before, when internet is up, what is the identity? Underlay IP address is what? 180. Does our controller, do they know how to reach 180 IP addresses? Yes, they know. They know how to reach 180 IP addresses because we have put a static route. Hey, controllers, if you want to go to any IP address in 180.10, you have to go via inet router. So they know the IP to reach 180. Same way on the controllers, we have put a static route telling that, hey, controllers, if you want to go to any IP address starting with 10, in 10 IP, then you have to follow, you have to go via the MPLS router. So these routes are there now. Now the thing is that when this thing goes down, when this is going to go down, LA1 is going to send traffic from here, right? LA1 is sending traffic from here basically. So when it is sending this traffic here, it is assuming the IP address now what? 10.111. This is the IP 65.2. This is the IP address of LAVH2, like that. Underlay, think of underlay now. So now LAVH1 is sending these packets. Source IP 65.2. Destination, let's say it is saying I want to go to my controller 192.168. 0 dot, let's say the controllers, only let's take 2.111. So it says I have this default route. So he forwards the packet to LA2. LA2, what it does? LA2 also has LA2 knows how to reach the controllers because his MPLS is up. So he forwards the packet to vmanage. Vmanage receives this packet. It says, oh, the source is what? 10 belonging. So what vmanage says, vmanage forward, let's say echo reply, he forwards the packet back to MPLS router. Now when the packet lands on MPLS router, this subnet 10.111.65.0, this subnet is not known to the MPLS router because LA2 has not advertised this. What is running here? BGP. Here there is BGP basically running like that. So I have not advertised this link in basically in BGP. So MPLS router will never know about this subnet here inside, and that's the reason all the control connections for LA1 has gone down, because when internet goes down, it is assuming a new IP address 10.111, and this MPLS router does not know about this. Where is this 10.111? So what we have to do, either we advertise this network command in BGP, or we can put we can tell the service provider we are having this subnet 10.111.65. So you put a static route pointing to us. So we'll do that quickly. I'll go here. I'll go to the MPLS router. You see MPLS router, if I do MPLS router, if I do show IP route basically on the MPLS router, output is See, it does not, see, it has a static default route pointing to the, that is for the internet. Then it has all this basically specific subnets basically, but it does not know, there is no route pointing to 180 also it knows. Like there does not have 10.111.65.0 subnet, does not know. So that's the reason I have to put a static route here, IP route 10.111.65.0 255.255.255.252. Gateway I have to specify will be gateway 10.111.1. MPLS router IP is what? 152. And dot 111 gateway 152. Yeah, correct. So this default route I have to put. Now LA VH1. Let us refresh. And there you see it has become again up. And now I go to again what? INET router is already shut down VPC. Let's see VPC can reach the resources now. VPC, but still is not able to access the company resources. VPC is not able to access the resources. Control connections issue is now controllers know where is LAVH1, but end users in service VPN, they are not able to access the resources. Why they are not able to access the resources? Again, analyze this. Here is this VPC. This user is forwarding the traffic to LAVH1. LAVH1, it is going to check its routing table. Routing table says if you want to go anywhere, go to 10.111.65. This one LAVH2, the packet basically lands here. This guy receives the traffic in VPN 0. It says VPN 0. I have what? I know I want to go to anywhere. LAVH2 will become like a forwarding device. It will check its routing table. Routing table says yes, you have this thing. Color is basically MPLS. Forward the traffic to data center. Data center guys. Suppose here MPLS router, here is the DC, DC1. So packet lands on DC1, DC1 forwards to router 12, router 12 sends the packet to this guy. This time now source IP is TLOC. TLOC will be what it says. This is the whatever the subnet. This is 10.0.111 subnet. So DC says if I want to go to 10.0.111.0 subnet, the TLOC is LAVH1. System IP is same, but okay, color is what? MPLS. And the TLOC, to reach the TLOC, what is the next stop IP? This IP. So 10.111, nobody knows. So actually what I should have done, best thing is what, on LAVH2, since it is BGP running in VPN 0, best thing is what, I should advertise this network command, this 10.111, so that everybody, all the other WAN edges will learn about this new subnet. That is what LAVH2 must do. So LAVH2 BGP, we have to do basically this one. Then only, because that is why it is failing basically. Let me do one time ping and let me go to router. Router 12 is anywhere. Did I start router 12? Yes, router 12 is up. If I say debug IP ICMP, and if let's say I do this ping here, from here, let's see the packet lands all the way up to there or not. No, because whole destination network is only unreachable. Yes, it is not even going there till the end like that, because TLOC is not available. So what we can do, LAVH2 now, but I cannot put through CLI the route static. It's not that easy. So we have, whatever we have to do through templates only, because it is we manage now. So single WAN transport, this is the MPLS. We have to go in the BGP template. What is the B? Let us see the BGP. What is the BGP template which is being used in VPN 0? VPN 0 BGP template, feature template. So this is where I have to go. Feature template, just type BGP, show me BGP templates. This is the one. We go, we have to edit. See, a lot of work is there, not that easy. TLOC extension feature, that is done. But now we have to take care of routing issues. So address family, we'll add a new network. Okay, network prefix, let's say I say add 10.111.65.0/30. Add this. This LAVH2 will advertise this in BGP, advertising it in BGP. But problem is now you see VPN 0 BGP committing this change affect the config 5 devices. Why 5 devices it gets affected? Huh? Why 5 devices it should get affected? Single WAN transport feature. It is using BGP template transport and VPN 0 BGP feature template. This BGP VPN feature template, if I go here, type BGP, show me BGP. So VPN 200 template is also there. Why 5 device has been added? For the MPLS, yes, this template is being, BGP template is used by everybody, all the WAN server except LAVH1. Yes. So it will get applied to everybody like that. So I don't want to advertise only LAVH2, this network command I have to edit. So now what to do? This template is common for 5 devices, but I want it to be done only. See, now I'll show you one more feature. This, where is that network command I did? Over here. This network command, what I did here, like that. Did not, it's not there. I can see I can make it mark as optional. I can make it mark as optional row. So I'll just put it, because this is meant only for 65.0/30. This is meant only for LAVH2. I'll put it, see option, mark it as optional. It automatically see become device specific, mark it as optional. So it will ask me now. Now I say update. Now it will say, it will ask me, say this is basically what LAVH2. Yes, for LAVH2 it is okay. I want it to be done like that. Now if I say configure action will be applied to 5 devices, attached to 4 devices. No, I say back. What I do now? I go here, edit. Okay, see here optional. See the prefix. Now I made it optional, it is not accepting. So now I specify here. No, this is LAVH2. You should advertise this subnet 65.0/30 prefix update. So only LAVH2, rest all is optional. I don't specify for the other guys. Now I don't have any problem. So only 10.111.65.0 subnet will be advertised only by LAVH2. If I don't make it optional, it would have got advertised by everybody. All the managers would advertise it like their own basically, because it's a common template which is being used by all. Or the other option would have been what? I made a copy. I should have made a separate copy of this BGP template, and for LAVH2 I could have used the separate BGP copy also. That way also I should. But see, this is a good, again, a new learning, where if you want a feature, you don't have, you have a common feature template, but inside the common feature template you have a feature which you want only certain managers should have that feature. All the managers having the common feature template should not have that feature. What you do, you make that feature as what? Optional. Once you make the feature optional, then it will prompt you like that. Wherever, whichever vantage you will enable it, those vantage only will display that feature. So like that also is possibility is there. Now I think everybody must know 10.111. In fact, MPLS router already knows. Let us go back again. iNet router VPC. Interface administratively down 0. It is still shut down. Interface. What is the interface? E0/2. This is the interface which is right now. It was shut down. Let us make it normal first. VPC should have reachability now. Yes, VPC reachability is there when normal internet is up. I'll shut down this now. Still VPC reachability is not restored. Users are not able to access company resources. Again, still routing issue is there. If I come to LAVH1, I say show IP route VPN 0. It is showing gigabit. This one is also there. It is showing this one is also there. Yeah, that is what I am thinking, because this is already there. It is still showing because even though because I made it floating, this is administrative distance is down. Let us make it again normal. Let us go back to iNet router. We have to come to iNet router, single WAN transport TLOC extension feature template. VPN 0 feature template TLOC, this thing, TLOC extension. This template, I'll make the administrative distance equal. Go to the IPv4 route section. We have this 2 gateways. We added this. Let us make it Normal default. Let's not play with this now. Normal is working. Failure. Ping. Gateway is up. Gateway 65.2 is up. Okay, one more possibility is there. See the diagram again. Okay, this internet has failed. Okay, this internet fails. Failure has happened where? On the LA side. LA1 side failure has happened. Traffic it receives, LA1 receives traffic from its service VPN. Service VPN traffic, it has a default route. It forwards the traffic to LAV2. LAV2 forwards the traffic through to its gateway MPLS router. MPLS router forwards the traffic, let's say, to this VDC, suppose. So DC will receive reverse traffic. Now it has received through MPLS, that like that. Okay, but VDC, this DC also has this basically connection here, internet. DC1 also has basically dual transport is there. Failure has happened here basically. So possibility is what? DC can forward the traffic here. If it forwards the traffic to this inet router, it is connected to the inet router internet. It comes here, and now inet router does not know LAVH1, that this subnet inet router does not know that where is this 10.111. Inet router, have I put a default route that for inet router, if you want to go to anywhere in 10. Let us check this inet router routing table. Do show IP route. Inet router, yes, I already given a static route that hey inet, if you want you get any packet starting with 10, you have to forward that packet to MPLS router, and MPLS router knows how to reach. MPLS router knows how to reach that IP, right? Ping. Why it is not working? What has happened here? MPLS router. I put a static route, right? MPLS router, right? MPLS router, I taught already a static route. Where that MPLS router static route is gone? I had configured MPLS router static route, na? Yeah, see, configured this static route, and I (10.111.65.0/30). Its route is there. If this is there, why this route is not there in the routing table? Yeah, it is there. Sorry. Yeah, it is there. So if it knows this is there, then why MPLS router is not able to ping 10.111.65.2? 65.2 is basically 65.2 is even LA2 itself. Why LA2 it cannot ping? MPLS router says I cannot ping this 65.2. Why it cannot ping 65.2? Because it has already this route. (65.1) it is able to ping. (65.1) it can ping. Yes, that is what I want. That is what I want. The MPLS router has reachability. Let me make the internet up. We manage. Let me shut down the interface. Single WAN transport inet. Single WAN transport TLOC extension. This is the interface is VPN 0 gear dedicated address. This interface is there. This template DIA cancel feature template. Say show me all the templates having DIA VPN 0. This is the template. Edit. Click it. Okay. For the time being, let's say I'm going to shut down this interface. I'm doing a failure on the LAVH1 itself. I'm going to fail this interface. Shut down. So now internet has not failed, the interface side has failed because in fact actually when I down the internet face, that time itself it changes. So internet has failed now, so it cannot go down there now. Still not going. Got stuck up. Huh? Where is the problem happening now? Now one vantage must go down. So you see it's still showing all the vantages. LAVH1, that means through MPLS it is coming. Through MPLS it is coming. It's not going down in the dashboard. The VPN 100. Black holes are failing. Because routing table shows like the VPN, show IP route VPN 100 when I do. See, it is showing only its own directly. It's not showing anything. It's not learning anything. LAVH1 has no routes. LAVH1, once the internet fails, it is not receiving any routes. Why it's happening basically? Who is giving the routing information to LA? The Vantages. vSmart is giving the routing information to the LAs. So when this internet is failing, let me bring up the internet back. Template, feature template, DIA. I'll make the interface again up. I want shutdown. I say no shutdown. Update. So when internet is failing LA1, basically, if there is no WAN service, LA1 is taking this IP. It is having this IP on LA1. I put a default route. I put a default route on LA1 that hey, LA1, if you want to go anywhere in the world, you have to go through LA2. So it is sending like that, trying to connect to the controller like that. Service VPN is this route. Now through OMP, it is learning and it is forwarding these routes. So it should advertise 2 TLOCs. Should advertise 2 TLOCs. vSmart. OMP peers. It has all the 6 OMP peers, all the 6 managers peer. LAVH1, this is LAVH1. I say OMP received TLOCs. So it says it is receiving TLOCs C22. It is receiving this one also. See, MPLS is there. LA1, it is showing normal. This is business internet. It's TLOC. It's real IP also. It is showing. Physical IP, it is also showing 65.1. This is its public IP internet. It is showing correct. So it has received this TLOC. Advertised TLOCs. Is vSmart advertising the TLOC? Is advertising LAVH2? Yeah, it is advertising LAVH1 also. Second TLOC also it is advertising. It is advertising MPLS TLOCs also. So everybody knows this. So why routes are not there? If I do again now, then the routes have come. Now the routes are back because internet is up. When internet goes down, in VPN 100, the routes are not there. Yeah, no, because this is not normal, no? This is not normal. Here OMP issue is there. Here this directly connected, everything gets redistributed. Through OMP, you're installing the routes in this thing. But when you're learning this through here MPLS, you're not installing the routes. LA1 is not installing the routes. So previous video, what I did, I added the feature templates, the sub interface feature templates which we created in the device templates for LA1 and LA2. So LA1 belongs to this template inet, and LA2 belongs, right? And then, but if the now this template will be needed by both, right? By
LA1 also and LA2 also. And for LA1, the default, the next stop cannot be same as LA2, because for LA1, the next stop will be LA2, and for LA2, the next stop will be LA1. So LA only, LA site has this issue. They don't have a backup. No dual transport. So whenever we create a new template, normally it goes in the bottom. So here is the template. Now we'll go and edit this template.
Where I'm missing the step. This is my same last session, last batch. It worked basically. Why am where I'm
If
missing?
I go to the IPv4 route section, you see it has a default route.
Yes.
Already one default route is there. Already one next stop is there. So how to add one more default route? We cannot create another new default route. We have to edit this default route itself. So I'll say now, I have to add one more device default route. Reason. Now this template will be needed by both, right? By LA1 also and LA2 also. And for LA1, the default, the next stop cannot be same as LA2, because for LA1, the next stop will be LA2, and for LA2, the next stop will be LA1. So we'll keep what? We have to keep it device specific only. And I'll just write it down. Basically, this is basically TLOC next stop. So we will write here TLOC next stop. Okay. I'm just going to write TLOC extension everywhere so that we know that basically what is the meaning of this field. We just should make it short. Is good. So device specific, so that we can tell what will be the next stop. No, it has only one. Where it went. It's a next stop.
Add extra one
So
more.
I should have done add. Save changes. I did, right? Yeah, it is showing. But it is showing only one next stop. Okay, this is the original one. Sorry. Oh, this will be normally. So I need to. This is the original one. This is not this thing. Okay. I need to correct this. This is basically no. This is your normal VPN 0 next stop. That is already there. Leave it. We will add one more next stop over here again. Now this I'll make it what? Device specific. And then here I'll say the key I want to assign will be what?
TLOC extension.
Specify finally in the end. Save changes. So now we should show there are two next stops. Save changes. Okay, see now the two next stops are there.
This step already I did, right? Same thing I did.
Which we are creating the new device template, which we are creating with now two default routes. One is the original, the default route to go anywhere in the world via the actual WAN transport. Now we go to the device templates. And now we need to edit the device template and apply the new device template, the new feature template for VPN 0. You go to the transport section. In the transport section, if you see it is having this original VPN, I say no, I don't want this one. We want to use this template, VPN 0 TLOP extension template.
Yes, same thing I did. Yes.
You say update. So now it will ask now. It will ask for providing the next of IP address.
Only the previous.
Green color tick. You see, it's not green color. Why? Because we have to provide the key value. So we select device template.
This I did global today.
So it is asking VPN 0 normal next stop. Who is my normal next stop? I'm on LA.
Sir, voice is not clear.
My normal next stop is basically
Sir, your voice is not clear.
dot
Which voice?
11
The video voice?
250. And then actually, okay, what will be your TLOC next stop? So TLOC next stop as per the diagram. I am on LA1. LA1, your TLOC next stop will be what? Then 155.65.2.
Today I made the change from 155 only, 111 I made.
155.65.
Dot 2.
Dot 2, correct?
Yes.
Dot 155.65.2, like that. So this is my outgoing interface and this is my next stop gateway. Okay.
One option is coming, okay. Oh, one thing is there. LA1 does not have the routes. VPN 100 routes, it is not receiving. When LA1 MPLS router. Ten subnet already. Smart knows how to go to IP address, any IP address in 10, it will be forwarding. So it knows LA1. It can ping 10.111. Yes, reachability is there. vSmart has reachability to LA1. If it has reachability, OMP should advertise the routes through OMP. vSmart should advertise all the routes to LA. LA1 real time. We say OMP received routes. Show filter. No, there is only no filter. VPN 100. .0 I'm receiving through vSmart. And it is installed also through MPLS also. Hello guys, what to do? Because is through MPLS the route as is not getting installed. It is telling invalid. Reason I think it's because there is BGP involved here. In MPLS cloud, BGP is involved. BGP it was learning. LA2 is learning, but the routes it is not forwarding to LAVH1. Same route. Take example this route like 170. This route. This is New York route. New York route. It is learning through vSmart. When it is learning through this one, MPLS, this one, LAVH1 says this is invalid. Same route it is receiving again one more time. It is receiving from vSmart, but it is receiving through business internet. That time it is telling it is not invalid. There is no INV. INV stands for invalid, unreachable. Here it is telling yes, this is reachable, basically R for reachable. So internet route is through internet, it is installing the route, but through when the same route LA1 is receiving through MPLS router, it is not a thing. VPN 100 is running OSPF. VPN 100 is actually OSPF is there. LABH2 when it is installing normally in the routes in VH1 VPN 100 it has to read this. OMP routes has to get advertised into VPN 100. OMP issue is there. Advertise connected, advertise static. Two devices attached. What are two devices attached? Dubai and New York. Because they are running BGP. OMP BGP. Here also here. BGP is on, but let me add this customized OMP template because it's an OMP issue only. Reachability is not an issue, routing is not an issue. So left out is overlay. Underlay, there is no issue. No, it's an issue of overlay. Because vSmart can ping LAVH1, it's a sub interface IP. That means underlay is up. Let's take 192. Still showing invalid. Still showing unreachable. MPLS, it is still showing unreachable. This route is unreachable through MPLS. Zero slash 1.2 0/1.2. One thing. Guys, now if this thing doesn't work now, we'll stop this, okay? Because I don't know how much time it will take. I will try to resolve this. I will record the corrected one, and then I will upload the what where exactly thing went wrong like that. That is the only way, because we can test now, because it is.
Sir, you can stop the recording, and that part where you are rectifying the issue separately, you keep it.
Yes, but now this current recording.
No, you stop it now.